Today's lesson, 10.1, Basic Probability. An occurrence for which the outcome is uncertain is called an experiment. The set of all possible outcomes of an experiment is the sample space of the experiment denoted by capital S. An example of this is when flipping a coin, I have my sample space, and I only have two possible outcomes, a heads or a tails. So my sample space is just heads or tails. And finally, an event, always denoted by capital E, is any subset of a sample space. Let's talk about me having four hats. I put one red ball under one of these four hats. Now, I don't exactly know which one it was, so if I were to guess any single hat, well, there's four hats, one red ball under one of the hats, I have a 1 in 4 chance of guessing the correct hat. What I'm doing here is I'm using essentially this probability formula. The probability of any event E is the number of ways to get the desired outcome divided by the total number of possible outcomes. Now let's talk about rolling a die. Before I even start trying to find the probability of anything, with a die, I know I have 6 possible outcomes. So, if I'm looking for a 2, well, only one side of a die is a 2, so there's just a 1 in 6 chance of me getting the desired outcome. If I'm looking for a number less than 4, well, on a die, 1, 2, and 3, that's 3. There are 3 numbers less than 4, so there's a 3 out of 6 chance, or just a half of a chance. Now, see a number greater than 7 on a die. So, there are 6 possible outcomes. 7 is not an option. So there's absolutely no way I could get a number greater than 7. The answer is 0. And for part D, finding that a number is less than 7, well, 6 numbers on a die are less than 7. There are only 6 possible outcomes. Probability of that occurring is just 1. Now, rolling 2 dice. If I roll a pair of standard dice, what's the probability that they land with a sum of 5 shown? This table I have here is every single outcome of 2 dice being rolled. I could roll a 1 and a 1, I could roll a 4 and a 4, a 5 and a 2, a 1 and a 4, a 6 and a 3, a 6 and a 6, a 3 and a 6, all of which are all possible outcomes. But what I'm concerned with is what is the probability they land with the sum of 5 showing? Well, that's only 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, and 1 plus 4 is 5. So there's only 4 desirable outcomes here. And then out of all of these outcomes, 36 of them to be exact, I've only 4 possible desired ones. So this reduces to just be 1/9. Now let us talk about a deck of cards. Every deck of cards we have, 52 card deck. There are 4 of each face value card, 4 different suits. 2 of those suits are red, 2 of those suits are black. So the probability of an ace. Well, there's 4 of every kind of card in this deck, so there are 4 aces. Out of how many cards in the deck? Well, 52. So I have a 1 in 13 chance of randomly drawing an ace from this deck. Now, the chances of the card in the deck being a red card. Well, I know that there are 26 red cards in a 52 card deck. So, I got a 1 in 2 chance of drawing a red card. Now, when thinking about how to draw a red king from the deck, I have 4 kings, but only 2 of those kings are red. So 2 out of the entire deck of 52 cards is a 1 in 26 chance of drawing a red king. And that's all for today.